The third chapter that we are going to start today is functions, and the first topic, the first video is obviously going to be the introduction on functions. So what are functions? So the functions, they are defined as mapping where every element of the domain, so when we say it's the every element on the domain, then basically every element of the domain means all the x values. These domain, they are called the x values. So all the x values, they are called the elements for the function. Every element meaning every value or every member of the domain here. It's mapped exactly onto one element of the range, meaning the y values. Like here, I can see it's -3 mapping onto -2, -1 mapping onto a 0, 1 mapping onto a 3, 3 mapping onto a 7, and 5 mapping onto a 5. So I can see every element of the domain has a unique value with respect to the y. These are the function values, and they are called one-to-one functions. When are they possible? They are possible when we have a linear function. Linear function meaning if I give you a function which is 2x plus 3, now this is a linear equation, this is a linear function. So with respect to that, if I say that the domain or the x values are 1, 2, and 3, I substituted x as 1, we got 2 times 1 plus 3 giving me the range which is 5. X as 2, substituted x as 2, the range is going to be 2 times 2 plus 3 giving me a 7. X as 3, substituted x as 3, 2 times 3, it's a 6 plus 3 giving me a 9. So I can say that 1 is mapping onto 5, 2 is mapping onto 7, and 3 is mapping onto 9. So this is called a one-to-one function. Every unique value is possible, and we call it a one-to-one function here. So the second example is with respect to many-to-one function. Now, what is many-to-one function? That is when we have the function equals to x squared plus 1. So function is a quadratic function, and I can say that this is an x squared plus 1. I substituted some of the x values or the domain values, and when I did that, x as -2, I can substitute x as -2. -2 the whole square is a 4, and 4 plus 1, that gives me the range or the function value, which is a 5 here. Then I substituted x as a -1. So f as -1, I was getting -1 the whole square, which is a 1. 1 plus 1, that gives me a 2. Substituted x as 0. X 0 here, my function value becomes a 1. Substituted x as 1, so 1 the whole square, that would give me a 1. 1 plus 1, that gives me a 2 here. Then I substituted 4, and 4 the whole square is a 16, and this value would then become a 17 here. So these are the range values that I have for the given function. Now what I see here is, the unique thing that I see here is that two of the values, -1 and 1, they were mapping onto the same range or the y value or the function value. -1 mapping onto 2, 1 is also mapping onto 2. Such functions are called many-to-one function, and this is possible for a function to be valid. So we got a one-to-one function, every function was unique. Then we have many-to-one function where we are saying that two of the x values are mapping onto the same y value. Many-to-one function, that is a valid function there. So moving on to the third case, we have one-to-many function. Now, what is a one-to-many function? If you are given an equation which is fx is equals to under root x, so I can say that under root x will give me the answer as equal to a plus minus the x value. Meaning in this function, if I substitute x as a 0, obviously the function value is a 0. If I substitute x as a -1, as a +1, I will be getting answers as a -1 and as a +1. With 25, I can get an under root 25 as a plus 5 and a minus 5. If I just sketch the function here, then for sketching, what I know is that this is the kind of a function which is passing through 0. This is the kind of a function where we can say that when my x is a 1, the y value is a negative 1, is a positive 1 and a negative 1 on the other side. If my x is a 5, then what I know is a 25. When my x is a 25, then what I know is that the y value can be a plus and a minus 5 here. So for such functions, the function validity is not possible. These are not valid functions. So I can say that one value of x cannot give me two values of x. So such functions, they are called one-to-many functions, and they are not defined as a function there. So to explain more on what they are, I can give example of 4 to 5 friends. So those 4 to 5 friends, they might be going to 5 different colleges. That is a possibility. So yes, that is a possibility that 5 friends are going to 5 different colleges. It's a one-to-one function, and it is a valid function then. If we go to many-to-one function, then for many-to-one function, what we can say is that out of those 5 friends, 2 of the friends, they are going to the same college. Like what I can see here is two of the friends, they are going to the same college. That is possible. I might say 3 of the friends from 5, they are going to the same college. That is also possible. So many-to-one function is possible, and they can be defined as function. But when we move to one-to-many, now, for those 5 friends, from those 5 friends, I cannot say that there is one of the friend who is going to 2 different colleges. One student has to get himself enrolled or can enroll in just one college. He cannot go to 2 different colleges. That's not possible for one person to go to 2 different colleges. So one to many is not a valid function. So this is how we can just remember for the validity of the function where it is possible or where it is not possible, where it is valid or where it is not valid. So one-to-one, unique, it is a possible function. Many-to-one, that is also a possibility, like 2x values giving me the same y values. Or even if I say for fx equals x squared plus 1, sketching the graph, what I can see here is that if I just sketch the graph, if I just sketch the parabola for x squared plus 1, I can see that this is the parabola for the function, and what we have said is when x is a 0, the y value is a 1 or the range is a 1, and we are getting two x values giving the same y value, meaning when x is a negative 1 and when x is a 1, the answer was equal to a 2, and this is a valid function then. So this was a many-to-one. So always remember, quadratics are always valid functions. So let's start some questions to explain more the concept of the ranges with respect to inequalities. So the first question that I have is to find the range of the function fx equals x plus 5. So I have been given the function which is fx equals x plus 5. This is the function, and they have given us the domain, and the domain is x is greater or equal to 5. Fx equals x plus 5, x needs to be greater or equal to 5. So with x as greater or equal to 5, the first thing that I did was to substitute x as 5 in the function. When I did substitute x as 5 in the function, I got 5 plus 5 giving me a 10. F of 6, meaning the x value is a 6, I was getting the function value or the range which is an 11. F of 7, substituted x as 7, 7 plus 5 giving me a 12 here. With respect to this linear function, I sketched the linear line, the graph, for which I said x is a 5, the y value was a 10. X is a 6, the y value was an 11. X is a 7, the y value is a 12. So what I observed here is that as the x or the domain values are increasing, the y values are also increasing here. So that I can say that for the domain x to be greater or equal to 5, my range, remember range is always represented with respect to fx. So the range fx is greater or equal to 10. Our next example here is with respect to fx equals negative x plus 5, and the domain that is given to us is for x to be lesser or equal to 5, meaning all the x values which needs to be less than 5 here. So I have substituted in the function x as a 5, that would give me minus 5 plus 5, which is equal to 0. And then I substituted the lesser values of 5, that is, I just substituted x as a 4, so that this becomes minus 4 plus 5, which equals a 1. Then I can go for f of 3, which is equals to minus 3 plus 5, which is equal to 2. So therefore, if I just sketch these points on the x and the y axes, what I can see is with 5, it was mapping onto 0. So I have it on the x axis here. With 4, I was getting a 1. So I can say that this is how the function is mapping itself. And then I have f of 3, which is giving me a 2. So this is how it should be on the y-axis. So that means if I just draw the line which is sloping up, what I can see about the function is that the function values as x was decreasing, as x is decreasing, x is lesser or equal to 5, I can see that my range is actually increasing from 0, 1, 2, and then so on. It's just going to increase. It's an open inequality. So in this case, I can say that if the domain of the function is x to be lesser or equal to 5, then the range of the function is going to be f of x, which needs to be greater or equal to 0. So this is how I shall be finding out the range of the given function with respect to the given inequality. Just sketch the function, get some values inserted for x, and get their range values and see if the function is increasing or decreasing, and set your range values then. So let's do another example to find more of the concept. Now the given function is h of x, which is equals to 2x squared minus 12x plus 22, and x belongs to all real numbers. X belongs to R, meaning x belongs to all the real numbers here. So x belonging to all real numbers, and this is the given function. First is to express h of x in the form a bracket x plus b the whole square plus c. So that is the completed squared form, which we already know how to solve. So if we start with the solution, I need to express 2x squared minus 12x plus 22 in the form which is a bracket x plus b the whole square plus c. I have to make the coefficient of x square as 1, and for that I can take the 2 common, so that I'll be left with x square minus 6x and a plus 11 here. Divide the coefficient of x, which is a 6, by 2, which will give me the answer as 3. So I will be adding 3 the whole square and also subtracting 3 the whole square to the equation. Then I can say it's 2x square minus 6x plus 3 the whole square, and 11 minus 3 square, meaning 11 minus 9, that would give me a plus 2 to the equation here. Now the first three terms here, they shall be represented as the algebraic identity, for which I'll say this is x minus, because coefficient of x is a negative, x minus 3 the whole square and a plus 2. Therefore, I can say that this function is 2 bracket x minus 3 the whole square, and 2 times 2 the constant would give me a 4 here. So this is how I can express it in the form of ax plus b the whole square plus c. From here, just additional information that we have done in the previous chapters also, that the turning point for this curve is going to be 3, 4. And also I know that the nature of this quadratic curve is going to be a minimum. Why do I need this information? To find the range. The second part of the question says find the range. So again, if I sketch this, I'm doing part B here. So if I sketch this on my x and the y axes, what I know here is that my x coordinate is a 4 would be giving me the y coordinate, my x coordinate as a 3 would give me the y coordinate as a 4. I can see that the turning point is a 3, 4. So I've just marked 3 on the x-axis, 4 on the y-axis, and here I can see that the curve has a minimum nature. So with the minimum nature, the minimum value that I can get for this curve for the function is a 4. So the rest of the values obviously are going to be greater than 4. I can see that the y-intercept is the constant in the equation, which is a 22, way greater than the minimum y value or the function value, which is a 4 here. So with respect to this value, I can say that the range h of x has to be greater or equal to 4 here. So this is going to be the range of the given function with respect to the domain, which said that my domain, the given domain was x belonging to all real numbers, and I can see that in this case x belongs to all the real numbers, and my range or the function values, they are greater or equal to 4. So this is what the introduction for functions is.